You are recording.
All right, we were just talking about implicit differentiation. And here's the problem right here, all right? This is a crazy curve. Now, I wonder why this curve has arrows on it instead of just dead ends.
Keep going.
It goes forever, exactly, and it keeps waiting out there, it's doing all kinds of crazy stuff, all right?
Oh, so it doesn't stop waiting.
Right, yeah, so it keeps waiting. This is most of it. It kind of settles down a little bit. Like from a distance, it looks like it's smooth, but if you zoom in close, it has little waves. But these are the big waves right here, okay? So let's say maybe you're in some kind of Johnson day as an engineer where you have to study some kind of wave, and you've got this crazy equation right here, okay? Well, I'll tell you what. On A, you can get y by itself in A. Just do a little plus or minus if you wanted to. In B, we said it would take some college math to get y by itself there, right? Okay, getting harder and harder. In C, no college math will help you here. You see how that y is super glued to the sign, but then this one's outside the sign? If you wanted to get that y by itself, the only way to break off a sign is to use the what? Inverse sign. But then as soon as you put the inverse sign and knock that one off, now you have an inverse sign stuck to this one. You can't get it free. You can't do it. Okay? Not even our number one mathematician of all times, Mr. Euler, could solve this for y because it's impossible mathematically. Like that. Okay? So we just went from one that you could get y by itself to one where if you take enough college math classes you can get y by itself to one that nobody can get y by itself. So if I say take the derivative and there's no way to get y by itself, your only hope is implicit differentiation. Right? That's all you can do. So we have to do an implicit derivative. Right? So if we can't solve for y, fine. We'll just do it implicitly is what it's called. It's the adjective. We'll just do it implicitly and give y prime by itself. It's okay. All right. So what is the derivative of y squared?
2y.
2y, and the chain rule is y prime. Okay. Minus. What is the derivative of sine? Cosine. What about the base? Stays the same, but then go back and do the chain rule. Now, what is the derivative of pi y? It would be pi. Okay, think of it like 2x. If you had 2x, wouldn't it be 2? Right? If it's pi y, it would be pi, but then y prime. Because the derivative of y is not 1, it's y prime. Okay? So the coefficient always carries, right? Doesn't it always carry? Okay? So I'll tell you that one. All right? Now, on the other side, the derivative of 2x is not 2x prime, is it? It's just 2. So everything here is with respect to x. So the x is just normal. Okay? It goes through the derivative process. The y does too, but you also have to remember the y prime. It's the only difference. Okay? And then, all right, pre-calculus, check. Now it's time for some algebra. Okay? I want to get y prime solved for. And I've got one here and I have one here. What should I do? If we factor that out, you can isolate. There you go.
The camera just died.
Oh, no.
Batteries.
I've got AAA batteries and you need AAA batteries.
Oh no.
Double. Oh, Matthew.
I'm sorry, guys.
Let's say goodbye.
Did it die?
You got a quick heads classroom, it's got all sorts of batteries.
I'm sure he does.
Nope, it's still recording.
Oh, well then we're good.
Yes, go to Mr. Johnson's class. And I'm sure he does have a lot of batteries. Oh, not that, no, not Johnson. Whoosh. Yeah. Anyway, it's just using engineering name, right? Mr. Smith's class, the physics teacher. Okay. All right. Now, what you do here is you factor out the y prime, and you have all this stuff left right here. Okay. To get y prime by itself, though, all we have to do is what?
Bye.
By all that business, and it'll go underneath the 2, and you should have an answer. 2 over 2y minus, oh no, wait a minute here. Certainly there's a better way to write cosine of pi y times pi. Oh, the pi is a number, so a number is a coefficient, yeah. So it's better, I wouldn't count off, but it's better to write pi times cosine of pi y, right? Okay, because it's a coefficient, okay? You're not going to write sine of x times 2, you're going to write 2 sine of x. Okay, okay. Hey, look, no fractions in a fraction. We got it. There it is. Okay?
So you
And that's what that is the formula to find the slope or steepness of this crazy curve right here. You'll find all the steepnesses.
find that in the vectors.
Yeah, actually, in this case, you don't. Usually it's a mixture. This time you just need a y coordinate. That's all you do. How about that? Interesting. So like every time it levels off, let's see, not many places actually where it levels off. In here would be close. That'd be close to zero, okay? That's a positive slope because it's going this way, right? This is a negative slope because it's dropping. See that? Positive slope, positive slope, negative slope. Okay? Matter of fact, this part's even more fascinating because this is obviously not a function, is it? It doesn't pass the line test. Good. You know what happens when you get a tangent line and you go out to the edge?
It goes through.
Okay? Go out right there. Remember what the slope of a vertical line is in middle school? It's undefined. Yes.
Ooh.
Anywhere this derivative is undefined, this function is undefined right here, would tell you where it goes vertical. How about that?
Should be at like apex of any kind
Kick
of.
back.
So you actually can figure out all the places where you go around the edge, just like that. Interesting. All right. Now, let's go on to example D. D is a crazy looking curve. Look at this one. D has a dead end at one side, and then it goes on forever on the other side. So it's like this, it's very jagged, very jagged. It's a little curvy. It's not a straight line. It's just slightly curvy, and then it curves like that. And that's a weird graph right there. Very strange graph.
What would you call that shape?
It wouldn't have a name. Don't even know. Now, once you get past this point over here, you start trying X and Y combinations, and none of them work. They don't work at all. Remember the square root graph? We've done a dead end before, haven't we? Remember the square root of X? Try plugging in negative X's and taking the square root of them. You can't do it. It's kind of like that. Okay? You can't use these numbers over here. They don't work anymore. Okay? Yes, Zach, there's Steve.
Are these graphs accurate?
They are, yes.
So why then, like, when it comes back, it goes back, like, to the left further than it originally did?
On this part right here?
Yeah, see that, the point goes further.
Well, you could do it by trial and error, but if you try the little X's and Y's, you would see that this one works just great, but not at that height. You get this height, a few more X's might work in the equation. Yeah, it's all in the balance in there. And then eventually it's just all about combinations, because it's like, what is X? Well, then what is Y compared to that? Right? Do they work or not?
So you can take derivatives of non-functions.
Yes, absolutely. Yep. Because you're still just doing steepness. And there are places like where a ski slope might go exactly vertical, and you still have to do that equation anyway. So even if it's not a function, we can still do the slope. Okay? So here's this crazy curve here, and you have to take the derivative. Now, once again, physically impossible to get y by itself. There's no way you can get rid of a natural log and a tangent at the same time, and then it's up in the power. You can't get y by itself. Okay? Impossible. But we still need to study its derivative. Thank goodness somebody came up with implicit differentiation, because we can do the derivative in its current implicit state. So here's a couple of good reminders about the old rules we did before, right? What's the derivative of natural log of y? 1 over y. Chain rule of y is y prime. Okay? Now, this is called a what? Exponential function. Who remembers the three-step process?
Keep saying.
Keep it the same.
Multiply by the natural log of the base.
Natural log of the base.
Multiply by the.
Chain rule of y is y prime.